age of electrical energy consumption that continues to rise at an unprecedented rate. This rising dependency on electricity within the UK has put significant strain on the power network and infrastructure. This and the ever-increasing UK renewable energy targets has put our energy industry in a crisis not just for resources, but also for the skilled workforce of qualified engineers that are in demand to address this massive issue. It is cited that the quality and quantity of graduates studying science, technology, engineering and mathematics is in need of attention within the UK energy market. This links back to secondary education, where there is now a decline in young adults studying physics and engineering modules. The decline has been linked to the lack of information and engagement pupils receive while studying such subjects, resulting in a lack of interest and therefore understanding on how these sciences play out in the real world.
The curriculum statements are there to allow energy and renewables to be studied. Certainly, some working models would stimulate interest and provide a focus for discussion. In addition, some design your own types of challenges or investigations looking at factors which would affect the efficiency of electricity generation would give pupils a practical context for their learning and show that engineering is fun.
We present our lab, an interactive landscape model demonstrating the UK's diversity of renewable generation capabilities. Our lab simulates the physical operation of generation sources and demonstrates how generation needs to be effectively managed for network consumption. Our lab features 6 generation sources laid out on a typical hill and coastal landscape. Lighting tracks are used to show the flow of power from each source. A load on the system is simulated with model houses. The model is controlled through a simulation program. The user can start a simulation which presents a real-life load demand plot and data for the site. The user is faced with the challenge of managing the network under the daily variations in wind speeds, solar availability, tidal patterns, and load demand, which is a reflection of the UK power network. While the user is able to control the model and gain a visual understanding of operating renewable technologies, power networking, and load management, they are also provided educational material on side panels linking aspects of their core curriculum to power industry engineering and renewables.
Our lab is designed with the intent to educate and generate interest in secondary school pupils towards the power industry, and hopefully encourage participants and observers to consider pursuing university studies in engineering for this ever-progressive industry. The model is also created for the public to better understand how our power network operates and the increased strain faced daily for our sustainable energy future. Our lab has already received interest from 2 major power industry companies, Siemens and Scottish Power Renewables. Both have expressed their interest and the benefits such a model could bring to the future of the industry's engineering force, as well as help to promote the study of engineering at university. Thank you for watching, and we hope you enjoy our lab.